Okay, today we're going to look at cubic functions in the form of a bracket x minus h to the power 3 plus k. So this is sort of like a little bit like the cubic turning point form. So when we graph all cubics, the implied domain is the real field and the range. And you can sort of see here, see how if we look at the domain, it takes on all x values and the range is taking on all y values. So therefore, we see the real field. Okay, so here in the red, we have our basic y equals x cubed. And you can see that it curves through and it has that turn where it turns from one way, or say it curves around here at that 0, 0. So that's at 0, 0. And that point is called the point of inflection. So if we have a look at the next graph, so we can see we've put, it's now 3x cubed, and you can see that it's become narrower. So the graph became narrower, but the point of inflection is still at 0, 0. Now, if we look at this final graph, we can see that we have a negative coefficient in front of x, so the negative. So that means it's reflected in the y-axis. So if you look at the red one went one way, but if we put a mirror along the y-axis, we would see the green one's gone the other way. But you can see also, because it's a half, it's a bit fatter, so it's a bit wider, but the inflection is still at 0, 0. So the a value narrows and broadens the graph, and if we look, if it narrows, we will see a will be greater than 1. So if it gets skinnier, if it gets wider, we'll see a is a number less than 1, or sorry, less than 0, or a negative number. Okay. Yeah, so if we see, sorry, smaller than 1. So if we see a negative, we will have a reflection in the y-axis. So the way we can find the point of inflection is using this h value and the k value. So you can see here, you find it at h and k. So when we have a minus, it becomes h. If we had a plus h, it would be minus h in the inflection. So we'll have a look at it. Okay, with the this plus or minus k, that's the vertical transformation. So plus or minus will move the graph up and down. So if we have a look at our example here, so if I drew a basic cubic, it would look like that. Okay, but what we have seen, if we do this one now, we have seen it's moved, the graph has moved up 2, so we might go 1, 2. So we'll now see the point of inflection happen at the 2. So it'll be 0, 2 will be the point of inflection. Okay, and then we can see from, so if I wrote the basic formula that we had before, we had x minus h cubed plus k. So you can see with our example, there's no h, so therefore 0, and the k is 2. So that's how we got that point of inflection. You can look at it that way. Okay, the h value moves the graph left to right. So if you have a negative minus h, or a minus number in there, that'll move the graph to the right. And if you have a plus a number, that'll move it to the left. So, and so for example, I'll just do a little quick example. So if we had x plus 2 cubed, so that would move the graph, to the left. Okay, so if you're quickly sketching that, remember a basic one looked like that. So then we've moved it to the left 1, 2. So we would see it doing like that or whatever. Okay. All right. So we're going to look a little bit more at sketching them anyway. So if we look at sketching our cubics, the first thing we should do is identify, identify the point of inflection and then find the X intercepts and Y intercepts. Let's have a look at one. So here in the example, so we can see that if we look at the point of inflection, the H value is 2 and the K value is 4. So the point of inflection is X is 2 and Y is 4. So that's where the graph is going to turn a little bit. And let's go find the X and Y intercepts. Okay, we may be asked to graph the inverse function of a cubic, which would be x to the power of a third. So the implied domain and range is still the real field, so that's where these r's are coming in. But if we remember back to when we did inverse functions, remember an inverse function reflects in this blue line, this y equals x. So here in the red is a basic cubic graph, and then here in the green is the inverse function. So if you have a graph to the power of a third, so that's the leading term or the degree of the polynomial is a third, this is the type of graph it'll reflect. It'll look like that. So just to remember your basic shapes. So if I go into the example here, so I've just done in the green the basic shape of a graph to the power of a third. Now let's sketch so we can see how that moves. So if we look at the point of inflection, so H is 1 and -2. So that's where we're going to see the inflection. So at in a basic one, the point of inflection is at 0, 0. So now we've moved it to 1 and say -2. So now it's here. So that's where that graph's going to change and point. So it's 1 and -2. So we'll do a similar shape, whatever it does, and goes like that. Okay, so we can go get our X and Y intercepts still the same way. So we'll let Y equals 0 for the X intercept. So we get +2 equals X minus 1. Okay, now if you're doing the moving that across, that's the opposite will be cubing. So we get X minus 1, so we get 8 equals X and minus 1, so 9 equals X. So that's my X intercept. So over here where it crossed, I'd write 9 and 0. And now do the X, Y intercept is when X equals 0, so 0 minus 1 power of third minus 1. So Y equals, now sine to the power of a third is the same as saying the cubic root minus 1. So the cubic root of minus 1 is actually minus 1. And then you've got another minus 1. So your Y intercept ends up being sorry, that should be minus 2. And then so your y-intercept ends up being minus 3. So you can see here we've got 0 and minus 3. And we pop that on our graph. Okay. Okay, so our last example is find the inverse function of this cubic to outside the brackets of x minus 3 to the power of 3 plus 3. So here. So if you remember back when we did inverse, what you have to do is you let x equal y and y equals x. So originally the question has this. And now what we're going to do when we're doing the inverse, you swap them round. So I'll put x equals 2y minus 4 cubed plus 3. And then we'll keep rearranging the formula. So I'm going to bring the 3 over. It'll be minus 3. And then I'm going to divide by 2. Bring the 2 over. So like that. Then I'm going to bring the 3 over. So you could, the cubic, the power of 3. You could do it, you could write it like this. Or it can just be, it's the same as saying to the power of a third. So I'll leave it like that. Okay, and then, so then we bring the 4 over. So we got x minus 3 third, over 2 plus 4 equals y. So therefore the inverse function, so that's the symbol for inverse function, is x minus 3 over 2 power of third plus